This video covers section 7.5 and 7.6, which is a section all about solving exponential and log equations. Every single one of these problems you'll solve for x, you either use a log or you will use the opposite idea of log to switch it to an exponential equation to solve it. So here we go. This is a exponential equation because the variable is in the exponent position. So to bring the variable down, we use log, the opposite operation. So we get x log 2 is equal to log 3. There's multiplication right there. So we, oops, 2, that's the 2. There's multiplication right here, so I'm going to divide the log 2 over. So x is equal to log 3 divided by log 2. You type this into the calculator and you get approximately 1.585. The next one, we cannot take the log of each side. We are going to use some algebra first to isolate this exponent part. So I'm going to subtract 8 over, which gives me 10 to the x power is equal to 1,000. I don't really need to do anything fancy here except for just think about it. 10 times 10 times 10. 3 tens multiplied together makes 1,000, so it's just 10 to the third power. On this one here, I will start off by taking the log of each side. That brings the 2x down to the front. Log 9 is equal to log of 66. There's double multiplication here. Multiply, multiply. So the opposite of double multiplication is double division. So I'm going to divide by 2 and divide by log of 9. Be careful when you type this into the calculator that you put an extra parentheses there or actually physically divide twice. These cancel out. X is by itself. So x is equal to log of 66 divided by 2 log of 9. Again, that has to be parentheses. You're typing this into the calculator, and which is approximately equal to 0.953. Alright, the next problem, we're ready to just go ahead and take the log of each side. I can't move anything around algebraically first. So I get x minus 2, that's one exponent, log 2, 12. Log 12 is equal to log of 20. There's multiplication right there, so I'm going to divide the log over. Always doing the opposite to solve my equation. I get x minus 2 is equal to log of 20 divided by log of 12. To get x by itself, we add 2 over. That cancels out. X is by itself. I'm going to leave it like that. That's the exact answer. So we just divide this on the calculator, add 2 to it, and we get x is approximately equal to 3.206. I have already typed these answers in to the calculator, so that's why I'm able to get them really quickly. This one here, you cannot touch the 1 or the 2, so we just go ahead to bring this down. This is the whole exponent, so we use the log to bring the exponent to the front. So it's 2x plus 1. Log 25 is equal to log 144. Again, there's multiplication right there, so we bring the log over, but division. So we get 2x plus 1 is equal to log 144 log of 25. Excuse me, I had a little tickle in my throat there. Now I'm going to do 2 steps to solve this. I'm going to subtract the 1 over, so that cancels out, and then I'm going to divide the whole thing by 2, so that cancels out. So x is equal to this whole mess right here. So it's log 144 divided by log 25. Subtract 1 from that, and then divide this whole answer here by 2. So if you're going to type this all at once into the calculator, you need to put a parentheses around all that business there. So x is approximately equal to 0.272. The next problem is almost the same thing. We just take the log of each side, and we get 3x minus 4 in parentheses. Log of 2 is equal to log 5. The multiplication right there can be gotten rid of by dividing the log over, just like we did in the last problem. So divide by Log 2 cancels out. So we get 3x minus 4 is equal to this fraction, log 5 divided by log of 2. Then we got to do 2 steps to get x by itself. We're going to add 4 over. That kills that part. And then divide by 3 to get x by itself. So this is very similar to the last one. X is equal to this mess right here. And so you divide it, add 4, divide. And again, if you're going to do this on the calculator all in one step, you got to make sure that you have extra parentheses right there. Answer 2.107. Now, this kind of problem is different. This is log. There's nothing for a base, so it's log base 10. And we're going to rearrange this base exponent answer. So remember, if you have log base 10 of 100, that's equal to 2. And the reason why that works is because this is my base, this is my answer, and that's my exponent. 10 squared is equal to 100. Remember, logarithms are base, answer, exponent. 10 squared is 100. So that's what I'm going to do right here, is change this out of log form to exponent form. So it's 10 to the negative 1 is equal to 2x. Okay, that's 10 to the negative 1 is 1/10. And we divide it by 2, and we get 5%. No, I get a nickel. All right, same thing on this one. It's 10 squared is equal to 3x plus 1. So we have 100 is equal to 3x plus 1. Move the 1 over, that'd be 99 is equal to 3x. Divide by the 3, and you get 33. Now on this one here, I'm not going to go base exponent answer. I'm going to get rid of the 2 first because I can. You always do simple algebra first. I can't touch this 1 right there. It's protected, just like I couldn't touch these here. So I get log of x plus 1 is equal to 2.5, 2.5. The base is 10, so we give 10 to the 2.5 is equal to x plus 1. Subtract the 1 over. 10 to the 2.5 minus 1 is equal to x. This goes into the calculator. It's a bigger answer. Just type in 10 to the power of 2.5 minus 1. It would be 315.228. Page turn. I'm going to use the properties of logs. Subtraction, remember, means division. So it's log of x over 3 is equal to 8. The base is 10. So it's 10 to the 8th power is equal to x over 3. So base exponent answer. Multiply each side by 3 to get x by itself. So it's 3 times 10 to the 8th power, which is 300 million. 300 million. So 300 million is equal to x, or scientific notation. Multiplication means addition, or addition means multiplication. So it's log of 2x squared is equal to 11, and this would be base 10 because there's nothing there. So it's 10 to the 11th power is equal to 2x squared. We're going to get x by itself by dividing each side by 2, and then we get 10 to the 11th power over 2 is equal to x squared. The opposite of squaring, of course, is to take the square root of each side. Now normally the answer would be plus or minus, because when you take the square root of x squared, there's 2 solutions that work for that. But if you go back to the original equation, you can't take the log of a negative number, so the only thing you can put in there is positive numbers. You can't even take the log of 0. So we can ignore the negative solution, and it's just the square root of 10 to the 11th divided by 2. Type that in the calculator. X is approximately equal to 223,606.8. I'm going to combine this together here into one thing. Bring the 2 up for the property here, so this 2 can come up here and be squared. Multiplication is addition, addition is multiplication, so it's log of 4x squared is equal to 2. So So I combined it together using the properties of logs. I do have a video about the properties of logs on one of my other YouTube thingies. The base is 10, so it's 10 squared is equal to 4x squared. That's 100 is equal to 4x squared. Divide by 4, that'd be 25. Take the square root. And again, when you take the square root here, you would get plus or minus 5 normally, but you can't take the log of the negative number, so the answer is just 5, not negative 5.